Assalamualaikum and salam sejahtera. My name is NOOR binti SHAMSOL. Me and my friends are gonna explain about our assignment. Okay. For the part B, first, find and modify an application problem that can be formulated as LP problem with at least 3 decision variables and 3 constraints. And this is the LP problem that we've already modified. The Hush Puppies manufactures casual shoes, boots and dress shoes for Aeon Mall. Aeon Mall will accept all production supplied by Hush Puppies. The production process includes designing, stamping and sewing. The daily available time for 3 productions are 430, 460 and 420 minutes respectively, and the revenues per unit of casual shoes, boots and dress shoes are 3 ringgit, 2 ringgit and 5 ringgit respectively. The manufacturing times per casual shoes at the 3 productions are 131 minutes respectively. The corresponding times per boots and per dress shoes are 204 and 120 minutes. Formulate a mathematical model of hush puppy situation to maximize the profit. Okay, from this LP problem, the first step is we must let the x1, the decision variable, we must let x1 represent number of casual shoes produced daily, x2 number of boots produced daily, x3 number of dress shoes produced daily. Okay, second step, objective function, which is to maximize the profit. Maximize z equals to 3x1 plus 2x2 and plus 5x3. Okay, the third step is the constraints. Okay, C1, the maximum daily available time for designing process is 430 minutes. So, constraint that we get, x1 plus 2x2 plus x3 less or equals to 430 because we use maximum. Okay, the maximum daily available time for stamping process is 460 minutes. 3x1 plus 2x3 less than or equals to 460. Okay, the third constraint, the maximum daily available time for sewing process is 420 minutes. Okay, x1 plus 4x2 less than or equals to 420. And the last step, we must list all the objective function and the constraints that we get. Okay, maximize z equals to 3x1 plus 2x2 and plus 5x3. Subject to the constraints that we get. And then the last one, don't forget x1, x2, x3 greater or equals to 0. So for the second problem, for the second question, solve the LP using Lindo or Excel solver. Okay, for this one, the the objective function value that we get is 1350. This is the Z value. And for the variable, x1 we get 0, x2 we get 100, x3 230. Okay, the select variable or surplus, s1 equals to 0, s2 also is 0, s3 equals to 20. Okay, for the range, for the objective coefficient range, D1 is from negative infinity until 4, D2 negative 2 until 8, okay, D3 negative 2.6667 until infinity. And this is the RHS for the right hand side range, which is for the D1 starting from negative 200 until 10, D2 20 until 400, D3 negative 20 until positive infinity. And this is the optimal tableau that we get for this LP problem. Okay, as you can see here, the previous Z value that we get is 1350, also 1350. And X2, this is X2. For the X2 row, 100. X3, 230. This is the surplus or slack variable. S3 equals to 20. Okay, next. For number 3A, my friend's gonna explain for her part.
For the third question, I will explain when there are changes on the right hand side. The first one is all conditions are feasible. The production process of sewing has increased at most 850 minutes per daily. So this one is the new LP model, which is I only changed the constraint 3. So the new value is 850 minus with 420. This is the original one. So I got the new right hand side value is 430. So by referring the feasible range D3 is negative 20 until positive infinity, the D3 equals to 430 is within the range. So this one is the original optimal tableau. Okay. To find the new optimal solution, I just consider with the D3 that I changed. D3 equals to 430 and D1 and D2 is equals to 0. Right. And then we calculate the new solution. The Z value we got is 1350. X2 100 is greater than 0, so it means that this value is feasible. X3 the value is 230 is also greater than 0, so this one is also feasible. And the last one is S3. I got the value is 450 is also greater than 0. So all this value X2, X3 and S2 is feasible range. So we can conclude that the current basis remains feasible with the new optimal solution value, which is X1 equals to 0, X2 equals to 100, X3 equals to 230, S3 450 with, and then I just substitute all this value into the original Z value. So after I substitute, and then I got the answer is 1350. Okay, from this calculation, I compared with the LP solver by using the new RHS, which is D3 equals to 850. Okay, this one objective function is the Z value that I got is 1350. This one is the same answer with this one. And then for the X value, X1 equals to 0, X2 equals to 100, X3 equals to 230. I also get the same answer with the LP solver, this one, 0, 100 and 230. For the slack variable, okay, S3, I got the 450. This one is also the same answer with this one. So from this answer, it is proof that the answer is same with the LP solver. And then we proceed with the next question. At least one of the condition is infeasible. The daily available time for stamping production process has increased at most at 900 minutes. This one is also the new LP model, and from this one, I just changed the constraint D2. Okay, this one is the new value 900, and then I minus with the original one 460, and then the new value of right hand side is 440. So by referring the feasibility range, D2 is negative 20 until 400. The value of D2 is equals to 440. It's not within the range. So the current solution, which is the S1, S2, and S3, does not remain the feasible. Because of the S1, S2, S3 is not the remain feasible. So the further calculations, we uh we have to further the calculations to find the new solution by using the dual simplex method. Okay. So the step is this one is the original optimal tableau, this one, and then from this we have to find the new optimal solution, and then we have to consider that D2 is equals to 440, and then the D1 and D3 is we consider it as a zero value, and then after we make a calculation, we got the value of Z, X2, X3, and X3. Okay, all the new value here, we just um we just we just change at the right hand side column. Okay, from here we change here, and then from this tableau, we have to choose the most negative. We have to choose the most negative row here, and then to select the entering variable, we have to find the ratio that has a negative coefficient in pivot row. And then we have to choose the variable with the smallest ratio as the entering variable. So here that I have highlighted that. And then after we make the calculation here, and then we have to update this tableau. We have to update this tableau, and then we can find the optimal solution, which is the x1 equals to 0, x2 equals to 0, x3 equals to 430, x1 equals to 0, x2 equals to 40, x3 equals to 420, and the z value is 2150. Okay, from this value, I compared with the LP solver. Okay, this one is the z value. It's the same answer with the this calculation. Okay, for the z value, for the z value, for the x value, x1 is 0, x2 0, and only x3 is 430. Okay, this one is the same. And then for the select variable, s1 0, s2 40, and s3 420 is also the same answer with the LP solver, this one. So from this answer, it is also proof that the answer is the same with the LP solver. So that's all from me. Next, we proceed with the next question.
Okay, for the next question, which is 3B, changes in the objective function coefficients. The first one is for the all conditions are satisfied. Jenny went to the Ion Mall and the price of the dress shoes has increased. Each dress shoes costs 6 ringgit. Okay, this is the original objective function. And this is the new objective function that we have changed. And we changed for the dress shoes cost, which is the X3. Okay, for the D3, we must subtract the new value with the old value. So 6 minus 5 equals to 1. By referring the optimality range of D3, which is negative 2.67 until positive infinity, D3 that we get equal to 1 is within the range. Therefore, the current solution that we get, x1 equals to 0, x2 equals to 100, x3 equals to 230, is still optimal, but with the new value of Z. Okay, this is the new value of Z that I have calculated. We get 1580. Okay, after we get the value, we compare it with the LP solver. As you can see, the Z value that we get is 1580. Okay, x1 0, x2 equals to 100, and x3 equals to 230. So as you can see, we get the same answer for the calculation that we have calculated manually with the LP solver. Okay, for the next question, at least one of the condition is unsatisfied. Lisa bought a pair of boots during Christmas holiday and the price of the boot has increased. Each pair of boots costs 12 ringgit. For the original objective function, which is the z equals to 3x1, 2x2 and 5x3 plus 5x3. Okay, as you can see, the pair of boot cost changed to 12 ringgit, which is the x2. So the 2 equals to 12 minus by 2, we get 10. By referring to the optimality range of D2, -2 until 8, D2 that we get 10 is not within the range. Therefore, the current solution is no longer optimal and we must find the new optimal solution. And this is from the given original optimal tableau. As you can see, this is the modified problem that we write in terms of D1, D2 and D3. We must after that we must find the reduced cost of NBV. Okay, as you can see here, in order to find the x1, 4 times by 1, -1 over plus 1 -1 over 4 times by d2 plus 3 over 2 times by d3 plus 2 times by 0 and minus with the top row element. Okay, same goes for S1 and S2. Okay, from D2 that we get equals to 10. D1 and D3 automatically equals to 0. After that, we substitute the value that we get here into the reduced cost. Okay, S1, we get 1.5, which is greater than 0, so satisfied. S1 equals to 6, greater than 0, satisfied. S2, but S2 we get negative 0.5, that is less than 0, unsatisfied. And the new Z value that we get is 2350. After we get all the value, we must substitute the value into the suboptimal tableau. As you can see here, x1 1.5, s1 6, s2 negative 0.5, z 2350. Okay, 1.5, 6, negative 0.5, 2350. Okay, after that we must use the ERO to find the new optimal solution. Okay, and this is the new optimal solution that we get. X1 equals to 0, X2 equals to 105, S3 we get 220, S2 we get 20. Okay, after that we compare it with the LP solver. As you can see, 2000, okay, Z value 2360, X1 0, X2 105, X3 220. Okay. S2 equals to 20. S2 equals to 20. Here. Okay, after that, we've also can get the optimal tableau. Okay, as you can see here, from this tableau, X2, Z. Okay, on top of the tableau is Z 2360, X2, X2 105, X3, X3 220, and S2. S2 we get 20. Okay, from the LP solver we get the same answer as the one that we calculated manually. Okay, that's all from us. Thank you.